Math 2920, Topic 4, Mathematics and Other Disciplines. Here we look at how mathematics can contribute to understanding things other than mathematics. In the problem solving so far in the course, we've had the situation where we've started with a problem that's been given to us. Then we've gone through this process which we call mathematical problem solving. So in one model, this is our Polya model where we've got an entry, attack, review. We've used the organized scribble approach. We've got our keywords like I'm stuck and aha, I'm getting somewhere. And so that gets all our working. And from that we distill out this formal piece of written mathematics, our write-up, which is where we put down all the good stuff and we communicate that to our peers. Now the thing about this is that it's all happening within the world of mathematics. The problem comes from mathematical topics. Our problem solving uses techniques which we're familiar with from our mathematical knowledge and skills. And our written solution is written so that it contributes back to our and our colleagues, our peers, resources that they can use for their own mathematical knowledge and their own mathematical problem solving. So in all, this process is seen as being, in a sense, within mathematics. Everything is within mathematics. The language, the concepts, and the context are all mathematical. However, much of the mathematics we do as mathematicians was actually originally set up to solve problems in the real world, not problems that had just come from mathematics. So they come from engineering, they come from the sciences, they come from business, from economics, they come from health, and pretty much any other discipline. So I've got this concept that out there is this real world, this messy real world full of buildings and cars, trees and people. And in this real world there are problems. Now if we're going to be useful mathematicians, what we want to be able to do is to turn these real world problems in some way into mathematics, turn them into mathematical problems that we can solve. This means we can come up with a solution, and if it's a particular good solution, then of course we get the accolades of our peers, we get fame and fortune. In a nutshell, this is what applied mathematics is about. Applied mathematics involves the use of mathematical tools and processes to solve problems from outside mathematics, real-world problems. Often when we're doing applied mathematics, we will develop new tools, processes, and theories. The good news is that most of this fits within our established framework of thinking and working mathematically. If we are going to work mathematically on non-mathematical problems, we need to translate our real-world problem into a mathematical version of the problem, a mathematical description of the situation. When we do this, we get what's called a mathematical model of our situation. You might wonder why we use the word model here. Well, in fact, it's the same sense in which you use the word model in other contexts. In particular, say we had a house that we were thinking of building. So there's an architect thinking of a house. Now, once he's had those ideas, one thing he can do is make a scale model of the house. Now, this model, what it does is it represents the ideas in the design of the house. Now, the real house that's built from these ideas can also be seen as being represented by the model. So you can see the role of the model is to represent things. And the purpose of the model is to give us a better understanding of the things it represents. So if we were using mathematics to model our problem, to model our real-world situation, we'll be using mathematical concepts such as numbers, variables, maybe something from geometry, maybe some other processes that we understand from mathematics, or some other part of mathematics. And we'll be using this to model aspects of our real-world situation. So as with the architect and his house, The purpose of having a model, mathematical or otherwise, is for the mathematics to actually tell us something about our real world situation, to help us solve the problem that we were originally tasked with. So we could be making a measurement, we could be getting some sort of analysis, we could be making predictions of what may happen under certain situations. We could be explaining why certain things happen a certain way, coming up with theories. So all of these are goals of modelling, of the modelling process.